Good morning, good afternoon, everybody. My name is Marco Carminati, and I'm a Global Direct Current Application Specialist. In this session, we'll go deeper in details about our circuit breaker. In particular, we'll talk about the existing series and the new developments we are making to meet the DC application requirements. As we have seen in the previous application sessions, these applications are becoming more and more common, and new applications are upcoming. So new and challenging requirements are becoming more and more common. For example, higher DC voltages, huge short circuit current, and converter protection. In ABB, we are committed to satisfy these requirements and to support our customer in this DC application evolution. In this session, we are going to have some valuable contribution from the R&D and the product management department. So, let me introduce now our colleague Davide Personeni, who is the product certification and documentation manager. Good afternoon, Davide. Can you give us an overview on DC from your point of view, and how are you involved in the DC world?
Good morning. Good afternoon. In regards to the DC common application, there are many large number of possibilities that can be used for the DC products, low voltage products, compared to the AC. Considering also that the renewable part that are strictly related to the DC is increasing. And due to that, the generation is more spread, and sometimes, let's say, very often, the size of the plants are smaller. And so there are many larger possibilities to have a different architecture of the plants. So basically, we can have solar farms where we have a photovoltaic circuit breaker, where the DC breaker are used to, for the first fault to earth. And on the other end, we have for example, battery, where typically in storage system, and in this case was also matter of the bidirectional circuit breakers. And another prominent example of market trend is EV charger, and especially for that we have the matter that larger system for EV charger are also including DC ground fault.
How do these trends find applicability in the standards?
So basically, from a standardization point of view, all this matter took place in the basically present product standard. For example, we have in the IC annexes for the PV in part 2 and in part 3 of the 60947 for PV application, as said. On the other hand, on the UL, especially for the molded case circuit breaker, we have the PV in the UL 489B. We have the stored energy with battery in the UL 489 part F, and we have the part G, UL 489G, for microgrids application circuit breaker. All these items arrive to the common boundaries of the DC for low voltage products, that is 1500 volts DC, obviously. From another hand, all this standard brings additional requirements, or they are increasing the severity of the test inside the basic standard. For example, in the UL 489 standard, the DC tests are become more severe, maybe due to that part relating to these specific annexes or standard or outline of investigations.
Thank you. And regarding the standards, do you have any case story you'd like to share with us?
There is an anecdote that is relating to the UL 489B, the part for the photovoltaic. Once there was the first release of the standard as an outline of investigation, the standard arrives to us with some strange matter, and we address it to the UL. And in the second edition, we found that they were changed. But then, working on the thermal part, because for the PV maybe are not so critical for the short circuit point of view, but they are for sure critical for the thermal matters. Once we dial with the 50 degrees calibrations, we found some matter a bit strange, and we suggest to UL to adjust a bit, and the following edition we found that. And so, in a certain way, we can say that we wrote the standard elbow to elbow with the UL engineers.
Thank you. An example about a circuit breaker certified in accordance with the standard you mentioned?
Oh, sure. There are someone that we are very proud of that, and even we are probably champion in the market. That is the T-Max T5, according the UL 489B and even F on the same products, 1500 volt DC moreover, and for sure we were one of the first arriving into the market. On the other end is a 4000 amps circuit breaker, Emax 2, where is under certification now for 100 kA, again at the rated voltage of 100 kA, both short circuit breaking capacity, but even withstand current. And even if we said about the generation spread, smaller implants, is really significant, the power that can be switched by this breaker.
So, does it mean that even for DC test capability are increasing?
Oh, sure, you got a very good point, because in regards to, for example, the Emax 2 E4.2, for the SOI values, 100 kA, 1500 volts DC, it's really hard to find many labs in the world that can deliver this power. One, for example, is our lab here in Bergamo. That is probably one of the most powerful lab in the world for the DC application. And on the other hand, but I've read just some advertisement, some lab in Far East would move to 200 kA again with the same rated voltage, 1500 volts DC. But maybe it's advertisement, I don't know. But also they are working with the lower time constant and not typically 15, 20 milliseconds like is possible in our lab. Moreover, try to breaking a bit the common boundaries of the low voltage DC application. Okay. We have the chance to test here in our lab up to 2000 volts DC, even if with delivering lower current. And again, in Asia, there are some other labs that in the near future will arrive to 2000 volts.
Thank you, Davide, for your contribution. Bye.
Thank you.
And now, let me to introduce you to our colleague Riccardo Breda and Nicola Perico, who are global product specialists for air and molded case circuit breaker. Good morning, guys. We are seeing that the capability to withstand the fault current is becoming more and more common in applications like battery energy storage system. Can you kindly explain us how we are approaching this requirement?
Thanks, Marco. With ACBs today, we can reach up to 100 kA ICW for 1 second. With that goal in mind, we developed our new switch disconnector based on Emax 2 air circuit breaker up to 1500 volts DC. But withstand current and breaking capacity are not the only parameters we have to consider when we choose a circuit breaker or a switch based on circuit breakers. We can also consider items like remote controls. With their circuit breaker and MCCBs, we can use accessories like shunt trips and under voltage release. Very common and very well-known accessories we can find in our breaker offer to have a full remote control of our breaker or switch. In other words, we can have the same remote control and same voltage and nominal voltage we find in all the controls circuits. And another parameter we have to consider is the speed of remote control we can have. With remote control made by coils, we can have the fastest control possible, and it's not only the possibility to control from a remote point, but also to make it faster than any manual activation. So those elements are very important when we have to choose between a generic switching device and a breaker-based switch or automatic breaker.
Auxiliary contacts are very important for the service continuity, but another important accessory for the service continuity is also the motor control unit. Motor control unit could be mounted on the device and allow customer to manage from remote the operation of the product. It is possible to supply the motor control unit with a wide range of supply voltages. Moreover, it is possible to find a wide range on ABB catalog in order to complete the configuration of the product, like, for example, mechanical accessories like handles or different kind of auxiliaries and other electrical accessories. It is also possible for customer to choose between different kind of installation. For example, it is possible to mount the small frames up to 250 amps directly on a DIN rail, or to have a fixed solution on a plate, or to choose between wireable or plug-in version that make the maintenance of the installation easy. Thanks to this wide range of accessories, it is possible for ABB to cover all the installation application and to give to customer great flexibility.
Thank you, Riccardo and Nicola. We know that this interruption has been very complex in the past. Can you explain us how we solved this issue and what are the several benefits of our DC solutions?
Yes, so DC current is not easy to break, and that's why for breakers we need to develop a specific solution internally and externally on every single breaker. Internally, for instance, we develop a specific arc chamber that helps to break DC current, especially for higher voltages. Externally, we need to connect poles in series to help the breaker making his own job. And that's what we do with the connection in series of pole. And to make it, we can also consider building manually, let's say, series connection, or use some of the solution we provide as a manufacturer, and we also suggest. We are talking about jumpers, so shorting bus bar or shorting links that we always provide with every single frame and every single breaker. For all the different network configuration we may have, we have different solution and specific solution. So we recommend to have a look on our documentation to pick up the best choice for each frame and for each network. Jumpers give many advantages. For instance, they are already provided in the right shape and with the right size to connect poles in series. So jumpers are the best solution to provide a quick and easy installation.
Yes, jumpers are an important accessories, but sometimes they are mandatory. There are two main cases where the mounting of the jumpers is mandatory. The first one is the UL installation, because all the tests for the UL are made with jumpers. So the jumpers kit is specified in the UL file, and it is mandatory to mount in order to have a UL listed product. The second case is installation where there are high voltage in DC. In this case, the device needs to manage a high value of energy, and it is important to have a great insulation between poles and also to manage the high temperatures on terminals. For this reason, it is mandatory to mount jumpers because they are tailor-made on the terminal dimensions of the ABB devices, and with the mounting of jumpers plus the phase barrier, it is possible to reach the insulation between poles and also to manage in an easy way the temperature on the terminals thanks to the heat sinks mounted directly on the jumper. In all the other cases, jumpers are not mandatory, but as ABB, we strongly recommend to use jumpers. First of all, because they are a time-saving solution. And second, because all the tests in order to declare the technical features on ABB catalog are made with jumpers. So, with the use of jumpers, customers are sure to have a device with the performance declared by ABB on the catalog.
This is our new switch disconnector E4.2 MS DC. This is based on Emax2 air circuit breaker, and we developed it with the target of 1500 volt DC. with specific solution for DC applications. Our new switch disconnectors cover both IC and UL standards. For IC, we have the utilization category PV2, meaning that it's the most demanding utilization category for IC. For UL, we have both UL 4A9B and UL 4A9F, so we cover photovoltaic application and energy storage solutions. Nominal currents are up to 4,000 amps IC and 3,200 amps UL. This is a global platform because on same breaker we can get IC certification, UL certification, and also CCC approval for China. It means that no matter in which country around the world we are providing our solution, we can get local and global standards all together on the same breaker. E4.2 MSDC is available in withdrawable and fixed version. And for both solutions, we provide the same ratings and same terminal in terms of shapes and dimensions. So no matter if you need to switch during your project from one execution to the other one, because ratings and terminal are the same. So we try to be more flexible and more close to everyday installations. One of the main aspects we try to guarantee is the installation flexibility. For instance, in this case, we have the connection of supply and loads from the upper side, and jumpers are provided on the lower side. In this configuration, we are interrupting both polarity of the DC network. We also have the possibility to connect and disconnect just one polarity of the connection. Terminals are provided in vertical or horizontal solution, like the one we can see here. We can use accessory taken from the standard Emax2 offer. So we can use widely known and already available devices on the same platform we can get from Emax2. E4.2 MSDC is the complete solution of switch disconnector up to 1,500 volt DC for applications like photovoltaic, energy storage solution, and many other DC applications.
With MCCB, we can cover application up to 1,500 volt in DC at 200 amps with a circuit breaker according to UL 489B and F, and up to 1,200 amps for the switch disconnector according to UL 489B.
Thank you again. We are seeing also that the bidirectionality is becoming more and more common in terms of requirement in application like, for example, battery energy storage system and EVCI, in which we have also the so-called vehicle-to-grid function. What criticalities does this requirement entail in circuit breakers?
Yes, this is a very important parameter that we also find becoming very popular, and we see testing our products that we face some issues or some challenges, like the short distance between poles for very high voltage can drive to insulation issue. That's why we develop our new Emax2 MSDC switch disconnector, and also we have our T4 MCCBs for voltage up to 1,500 volt DC.
Thank you. And which product are UL certified for DC applications?
For ACBs, we develop our solution in UL 4A9B for photovoltaic and the UL 4A9F for energy storage systems.
With MCCB offer, we can cover application up to 1,500 volt DC, up to 200 amps, according to UL 489F and B, with the T4 circuit breaker for DC application. And for the switch disconnector, we can cover application up to 1200 amps at 1000 volt DC, according to UL 489B, with the T7 switch disconnector.
Thank you again. And why do we prescribe often to use the shunt opening and under voltage release to open our multi-decay circuit breaker and the switches connectors?
Yes, in some cases it is mandatory to mount opening releases inside the device. The reason is that the DC current is not easy to be interrupted. So we need a very quick operation in order to don't stress too much the contacts of the device. For this reason, it is necessary to opening the circuit breaker or the switch disconnector with an opening release, because in this case the operation is quicker than a manual one.
Okay, just last question. What about the time constant during the interruption phase?
Yes, time constant is an important value for the circuit breaker. It is given by the international standard and represents the duration in milliseconds of the short circuit during the test in laboratory. It is possible that the same circuit breaker has different breaking capacity according to different time constant. For example, on our catalog, it is possible to find for the T4 MCCB two different breaking capacity, 25 kiloamps with a time constant of 1 millisecond and 10 kiloamps with a time constant of 5 milliseconds.
Thank you, Nicola and Riccardo, for your contribution. Bye. And thank you all for joining us in this session. Goodbye.